In this lesson, we're going to be solving radical equations. And there's kind of a process and an organization to this. The first thing we're going to look to do is we're going to isolate the radical completely. All right? And then we need to actually question, should we continue or not? Because if you have a square root or a fourth root or a sixth root, whatever the even root is, if it equals a negative, you shouldn't continue. Because square roots can't equal negatives, fourth roots can't equal negatives, and we're not talking about imaginaries or non-reals in this situation. So we would just stop at that point and say no solution. If it's an even root equaling a positive, like square root equals 1, fourth root equals 1, or whatever the positive number is, go ahead and continue. And then if you have an odd roots you don't have to worry about it at all, because cube roots of values can equal positive and cube roots of values can equal negatives, or fifth roots or seventh roots, they can all equal positives or negatives. So whether you should continue or not is going to depend upon your situation. And if you can continue, then we'll raise both sides of the equation to get rid of the radical, and then we'll solve because we'll have left what's inside the radical and plug it back in, make sure it works. All right, so for example, directions are going to say solve. So for the first one, let's say we have the square root of x equals 8. All right, so first thing, absolute value, or the square root is isolated. So, and it's not a negative, because we're dealing with an even root, so then we can try and get rid of the square root. And to get rid of a square root, we will square both sides. Squares and square roots undo each other, so square root and a square cancel, and you're left with just whatever's on the inside, and 8 squared is going to equal 64. So if you plug that back in to the original, square root of 64 would get you 8. So let's do another one. So if you have the square root of x equals negative 8, this is where you need to pause for a second. Square root is isolated, but square roots can't equal negatives, so we can't continue. We're not dealing with imaginary and non-reals, so that is a no solution. All right. So number 3. Let's say you have the square root of 2t plus 4 minus 10 equals negative 6. We're asked to solve that one. So very first thing is it isolated? The square root, is it isolated? No. So we're going to need to bring the 10 over. So we'll add 10 to bring that over to the other side. And these two will cancel each other out. That'll leave us with a 4 over here and a square root of 2t plus 4 here. So square root is isolated, it equals a positive, so we can continue. We will square both sides to cancel out our square root. So that will leave us with a 2t plus 4 on the left side, 4 squared is 16 on the right, and we solve away. So we'll subtract 4, and that'll give us a 2t equals 12, divide by 2, and we'll get t equal to 6. And if we plug it back in, do all the math, it should work out just fine. All right. Next problem. So for number 4, let's say we have a negative 3 times the square root of x plus 5 equals 15. All right, first question always is, we need to isolate. Do we have it isolated? No. So we need to get rid of this multiplication to our radical. So to get rid of that, to undo multiplication, we're going to divide both sides by negative 3. So to get that done, these will cancel each other, and you're going to have the square root of x plus 5 equals negative 5. Now before we keep going, should always question, square root, can a square root equal a negative? No. So that's a no solution. All right, number 5. So if we have a negative 2 times the cube root of x minus 2 minus 9 equals negative 5. All right, we need to isolate the cube root. So, going to take a couple steps to do that. Very first thing is we're going to get rid of this subtraction of 9, and then we'll deal with the negative 2. So we're going to add 9 to both sides. That's going to leave us with a negative 2 times the cube root of x minus 2 equals 4. All right, same thing that we had up here. We need to get rid of that multiplication. We need to get rid of the multiplication of negative 2. So we're going to divide by negative 2. So that will leave us with the cube root of x minus 2 equals negative 2. And same question, should we continue? Cube roots don't matter, odd roots don't matter. We can have positives or negatives. So perfect. So to get rid of a cube root, we'll cube both sides. So cubing both sides will undo the cube root and just leave us with x minus 2. Negative 2 cubed is going to give us a negative 8. We'll add 2 to both sides. And so that'll give us an x equals negative 6. And we can plug that back in, make sure it works. All right. So what if we have square roots on both sides? You have the square root of 5z minus 1 on one side and a z plus 1 on the other side. As long as you have the square roots on both sides, then really to get rid of it, you do the same thing as if the square root is only on one side. You square both sides, which works out great because the squares and the square roots will cancel each other. You're going to be left with 5z minus 1 equals z plus 1, and you solve away. So I'm going to subtract the z over to the left side, which means I'm going to subtract the 1 over to the right side, subtract 1, or add 1 to both sides. So 5z minus z is 4z, and then the z's cancel here, and you're left with 2 on the right side. Divide by 4, and we'll get z is going to equal 1/2. And then we can plug it back in, make sure everything works. So one more. If we have a t equals 2 pi times the square root of L divided by 32, and we want to solve for L. We're going to try and get that L out of the radical and everything else away from it. So first thing is, treat these like numbers, and pi is just a number. So we have a number multiplied to the square root. So no different than what we would have done before is we want to try to isolate the square root. So we want to get rid of this multiplication, so we'll divide both sides by 2 pi. All right, so that will cancel, and you're going to have t divided by 2 pi on the left side. On the right side, we're going to have this radical. All right, again, no different. We're going to try to get rid of the square root. We've isolated it. We're going to square both sides. So on the left side, we're going to take this square and apply it to everything on the inside. So that'll be t squared. That'll be a 2 squared, which will be 4. And then pi squared. On the right side, the square and the square root cancel each other. So you're just left with L over 32. So we need to get rid of this division of 32 that's attached to the L, or that's working with the L. So to undo the division, we're going to multiply both sides by 32. That way those will cancel each other. So the L is going to be by itself. This is technically over 1, and we can reduce the denominator with the numerator. So 4 goes into both 1 time and 8 times. So that'll get us an 8 t squared over pi squared, because the 4 reduced away. And then 32 is gone, so you just have an L on that side. All right, and that was solving radical equations.